Hi everyone, welcome to Calculus with Jackie and Shadow. We're going to be using eagles to learn calculus. So let's get started. We're going to just do a little warm up here. So let's say that Jackie is going to fly along the x and y axis. She's going to fly sort of in some sort of path along the x and y axis. And she flies in a path, her graph of her position looks like this. Now, what let's say we wanted to find her y position at x equals 6. Well, if we look at the graph, it looks like it's around 3. And let's see if we can kind of go around the graph. You get really close to 6, and the y position gets really close to 3. The same thing happens from the other side. Get really close to 6, it gets to 3. And so that's not even calculus. That's just looking at the graph. But it connects to calculus in an interesting way because now take a look at this. So now shadow is going to fly along the x and the y axis. And they call him shadow because he enters the shadow realm just for one instant. He enters the shadow realm. Doesn't exist in this dimension at all. You can't find him on the x or y axis. And you can see it just flies along the graph, and then there's a missing one little point in the graph that's missing. What would his y position have been if this didn't happen? And we're talking about x equals 7. So we can do the same thing as before, where we go around, and as we get really close to it, we can't quite get there, but it looks like it's getting pretty close to 2, and also from the other side, it looks like it's getting pretty close to 2. So we could say that if shadow didn't enter the shadow realm at x equals 7, his y position would have been around 2. And that's your first calculus, everyone. Uh, Now let's talk about something called instantaneous rate of change. An instantaneous rate of change is, well, it's kind of hard to understand. So let's take this function f of x. An average rate of change would be between 2 points. What's the average slope of the line between them? It'd be x1. It would be y2 minus y1 over x2 minus x1. He did that in algebra. So that's the average rate of change. But what if we wanted to find the instantaneous rate of change? Now that's where limits can be useful, because with a limit, you want to just get as close as you can to something. You want to get infinitely close. And as you can see, we got this line right here. And finding the instantaneous rate of change, it's like finding the tangent lines, find the slope of the tangent line, which touches the graph at only 1 point. So if you see they have this line right here, it's pretty close, but we can do better. So let's draw this other line. Now this is closer, and this third line is really close. It's almost perfectly tangent to this graph. So this little difference between y2, y1, and x2, x1, it's almost the instantaneous rate of change. You could also think of the instantaneous rate of change is if Shadow's flying around and he just like smacks into your face or something. Like, how hard is he going to hit you at that time? Like, how fast is he going at that exact instant? That's another way you can think about it. And let's look at an example here. So now Gizmo takes off from the nest, and there's this camera that's tracking her distance traveled in meters. And that's gonna be your x, distance traveled in meters. and it's at 2 seconds after taking off. The camera momentarily stops working at t equals 5 seconds. So you can see we have this table right here, and you have t1, 2, 3, 4, 5. Now, first of all, what is Gizmo's average velocity from t equals 1 to t equals 9? Well, at t equals 1, it's going to be just y2 minus y1 over x2 minus x1, although y is x and x is t, so it's going to be x2 minus x1 over t2 minus t1. So that's 105 minus 7 is 98, and 9 minus 1 is 8. So it's going to be 98 over 8, and it's 12.25. So you could say Gizmo's average velocity is 12.25. Now, this is where calculus comes in. Estimate how fast she's going at t equals 5. So if you were to take a guess of how fast she's going at 5 seconds, even though the camera's not working, well, what you'd want to do is you get as close as possible to t equals 5. So you have t equals 4 and t equals 6 right here. We have 44 and 68. So 68 minus 44, that's going to give us 24. And 6 minus 4 is 2. That's going to be 24 over 2 is 12. So you could say at t equals 5, Gizmo might be going around 12 meters per second. So that's the first lesson of calculus. I'll see you next time.